Welcome to our YouTube channel Skill Tech Edu, sharing and learning. Our today topic of discussion is types of compressor.
Types of compressor. A compressor is selected by 1. Required pressure, 2. Volume of gas required. Types of compressor: piston compressor, screw compressor, rotary compressor, dynamic compressor. Piston type compressor. The piston compressor are those which work on the principle of displacement compression. Types of piston compressors: single-acting compressor, double-acting compressor, diaphragm compressor, two-stage compressor, combined two-stage compressor. Single-acting cylinder. A single-acting cylinder is a type of pneumatic or hydraulic cylinder that operates with pressure applied to only one side of the piston. Here are the key characteristics of single-acting cylinders. Piston movement. Unlike double-acting cylinders where the piston can be moved in both directions, extend and retract, using pressure, single-acting cylinders are designed to move in only one direction, usually extend, when pressure is applied. Operation. Single-acting cylinders typically use compressed air or hydraulic fluid to move the piston in one direction. The return stroke is usually achieved by a spring or an external force, like gravity, rather than using pressure. Applications. They are commonly used in applications where there is a need for force in one direction only, such as clamping, lifting, and pushing operations. They are simpler and often more economical than double-acting cylinders for such applications. Design. The design of a single-acting cylinder includes an inlet port for the pressure medium, air or hydraulic fluid, on one side of the piston, while the other side typically has an outlet port for fluid to return or has a built-in spring to facilitate the return stroke. Advantages and disadvantages. Advantages include simplicity, cost-effectiveness, and suitability for certain specific tasks. Disadvantages include limited functionality, only one direction of force, and potential reliance on additional mechanisms, like springs, for the return stroke. Diagram of single-acting cylinder.
Double-acting cylinder. A double-acting cylinder is a type of pneumatic or hydraulic cylinder that uses compressed air or fluid, such as oil, to move in both directions. Here are some key characteristics and workings of a double-acting cylinder. Construction. It typically consists of a cylindrical barrel, a piston rod, and two ports, inlet and outlet, for the air or fluid. The piston divides the cylinder into two chambers, one on each side of the piston. Functionality. Extension. When compressed air or fluid is supplied to one side of the piston, the rod end, it pushes against the piston, causing it to move in one direction, extending the piston rod outwards. Retraction. When air or fluid is supplied to the opposite side of the piston, the cap end, it pushes against the piston from the other direction, causing the piston rod to retract back into the cylinder. Applications. Double-acting cylinders are commonly used in various applications where controlled and consistent linear motion is required, such as in industrial machinery, construction equipment, robotics, and more. Advantages. Provides force and motion in both directions. Offers precise control over the movement of the piston rod. Can be used in applications requiring both pushing and pulling forces. Control. The direction and speed of movement of a double-acting cylinder can be controlled using valves that regulate. Diagram of double-acting cylinder. A diaphragm compressor is a type of positive displacement compressor that uses a flexible membrane or diaphragm to compress gas. Here's how it typically works. 1. Diaphragm assembly. The compressor consists of a chamber with a flexible diaphragm or membrane that moves back and forth. 2. Gas inlet. The gas to be compressed enters the chamber through an inlet valve. 3. Compression stroke. The diaphragm moves inward, reducing the volume of the chamber. This increases the pressure of the gas inside. 4. Outlet valve. As the pressure inside the chamber exceeds the outlet pressure, the outlet valve opens, allowing the compressed gas to exit. 5. Exhaust stroke. The diaphragm then moves outward, increasing the chamber volume, which decreases the pressure inside and allows more gas to enter through the inlet valve. 6. Cycle repeats. This cycle of intake, compression, and exhaust continues in a repetitive manner, driven by an external source such as an electric motor or an engine. Key features and applications: oil-free operation. Diaphragm compressors are often preferred in applications where oil contamination must be avoided, such as in medical and food industries. High purity. They can compress gases without contamination, making them suitable for handling sensitive gases or where purity is critical. Variable displacement. The compression ratio can be adjusted by controlling the stroke length or diaphragm movement, allowing flexibility in operation. Quiet operation. Compared to some other types of compressors, diaphragm compressors can operate more quietly. In summary, diaphragm compressors are versatile machines used in various industries where clean, oil-free compression of gases is required. They offer reliability, efficiency, and flexibility in gas compression applications. Diagram of diaphragm compressor. We would discuss two-stage and combined two-stage compressor in next video. A screw compressor is a type of rotary compressor that works on the principle of positive displacement. Here's a breakdown of how it operates. Rotary screw mechanism. A screw compressor consists of two interlocking helical rotors or screws, male and female rotors, that rotate in opposite directions within a casing. The rotors have grooves or threads cut along their length, which mesh together closely but do not touch each other or the casing wall. Compression process. As the rotors rotate, air or gas is drawn into the compressor through an inlet port. The volume between the rotors and the casing decreases as the rotors continue to turn, causing the air or gas to be compressed. The meshing of the rotors traps the air or gas between the grooves and carries it towards the discharge port. Sealing and lubrication. The tight clearance between the rotors and between the rotors and the casing ensures efficient compression. A lubricant, often oil, is injected into the compression chamber to seal the gaps between the rotors, reduce friction, and carry away heat generated during compression. This lubrication also helps in cooling and sealing the internal components. Discharge. After compression, the compressed air or gas is discharged through an outlet port at the end of the compressor. It is then usually directed into a storage tank or directly into a distribution system for use. Advantages. Screw compressors are known for their efficiency and reliability in delivering continuous compressed air or gas. They are suitable for high-volume applications and can operate continuously without a significant increase in temperature. Applications. Screw compressors are widely used in industrial applications such as manufacturing, construction, automotive, and more. They are also found in refrigeration and air conditioning systems for compressing refrigerants. In summary, screw compressors provide a reliable and efficient method for compressing air or gas through the use of interlocking helical rotors that trap and compress the fluid as they rotate. A screw compressor. Rotary compressors are widely used in various applications due to their efficiency and compact design. Here are the common types of rotary compressors. 1. Vane compressor. O uses a rotor with slots for vanes that slide in and out. O as the rotor turns, the vanes trap and compress the gas. O commonly used in small industrial applications and HVAC systems. 2. Scroll compressor. O uses two interleaved spiral-shaped scrolls, one stationary and one orbiting, to compress gas. O gas is progressively squeezed and compressed towards the center. O known for its quiet operation and efficiency, often used in HVAC systems and refrigeration. 3. Lobe compressor. O employs two parallel rotors with lobes that mesh together. O gas is trapped between the lobes and compressed as the rotors turn. O used in applications requiring higher pressures and in specialized industrial processes. Each type of rotary compressor has its own advantages and is selected based on factors such as required pressure ratio, capacity, efficiency, and application specifics. Diagram of three types of rotary compressor: 1. Roots blower, 2. Vane compressor, 3. Scroll compressor. A dynamic air compressor is a type of machine that compresses air using dynamic principles, typically by accelerating air through rotating components to increase its pressure. Unlike positive displacement compressors that physically reduce the volume of air to compress it, dynamic compressors work by imparting kinetic energy to the air and then converting it into pressure energy. Centrifugal and axial compressors are both types of dynamic compressors used extensively in various industrial and mechanical applications where compressing gases or air is necessary. Here's an overview of each type. Centrifugal compressor. 1. Working principle. A centrifugal compressor converts kinetic energy into potential energy by accelerating the gas or air radially outward in an impeller. This kinetic energy is then converted into pressure energy as the gas is directed into a diffuser where its velocity is reduced, resulting in increased pressure. 2. Design and construction. Centrifugal compressors typically consist of an impeller with radial blades that rotate at high speeds within a casing. The impeller accelerates the gas towards the center and then outward, increasing its velocity. The casing directs the gas flow and houses the impeller and diffuser. 3. Applications. Centrifugal compressors are commonly used in applications requiring medium to high flow rates and moderate compression ratios. They are found in air conditioning systems, gas turbines, turbochargers for internal combustion engines, and industrial processes where large volumes of compressed air or gas are needed. 4. Advantages. Centrifugal compressors are known for their high efficiency, reliability, and ability to handle large volumes of gas. They are suitable for continuous operation in industrial settings and are often used in installations requiring significant compression power. Axial compressor. 1. Working principle. An axial compressor operates by continuously adding velocity to the gas or air as it flows through a series of rotating and stationary blades, rotors and stators. The gas passes through multiple stages of compression, with each stage increasing the pressure incrementally. 2. Design and construction. Axial compressors consist of a rotor assembly with blades that rotate at high speeds and stator blades that are stationary. The rotor blades accelerate the gas axially, and the stator blades redirect the flow and further increase its pressure. Axial compressors are designed with multiple stages to achieve higher compression ratios. 3. Applications. Axial compressors are commonly used in aircraft jet engines, gas turbines, and certain industrial applications requiring high efficiency and compact design. They are favored in situations where a high pressure ratio, compression per stage, is needed, such as in aviation and power generation. 4. Advantages. Axial compressors are efficient at handling high flow rates and can achieve significant compression ratios. They are compact relative to the amount of compression they provide, making them suitable for applications where space is limited but high power density is required. In summary, centrifugal compressors are characterized by radial acceleration of gas through an impeller, while axial compressors use axial acceleration through stages of rotating and stationary blades. Each type has its strengths and is chosen based on factors such as application requirements, efficiency, and the specific characteristics of the gas or air being compressed. Diagram of centrifugal compressor. Diagram of axial compressor. Thanks for watching.